Thank you for trying this demo.
Let's go hawak kamay, together we will soar high. Let's sing with a smile, OCNHS-TV.
Good day, everyone. I am your Mathematics 10 teacher, Miss Irene Joy Biberlido. I am here to help you in developing your logical and critical thinking skills. Is your module ready? How about your pen and paper? Great! Now, let's begin a fun and exciting lesson for today.
This is Mathematics 10, Quarter 1, Week 1, with the lesson Generating Patterns.
For this lesson, you are going to learn, number 1, generate pattern from a given succession of objects, numbers, letters, or symbols. For number 2, find the nth term of a sequence. And lastly, for number 3, write the rule for the nth term of a sequence. When you were in grade 8, you learned about the concepts related to generating patterns like inductive reasoning. The knowledge and skills that you acquired are very important for you to understand how to generate patterns and sequences. Hence, let us review inductive reasoning and perform the activity that follows. But first, what is inductive reasoning? Inductive reasoning is the process of observing data, recognizing patterns, and making generalizations or conjecture from observations. A conjecture is a conclusion made from observing data or an educated guess based on patterns. But what is a pattern? A pattern constitutes a set of numbers or objects in which all the numbers are related to each other. For example, patterns can be set of letters, set of numbers, or set of objects. As a review, get your notebook and pen and let us try this activity named Complete Me. For the instructions, make a conjecture about each pattern, then use the conjecture to draw or write the next term in the pattern. For number 1, the numbers are 1, 8, 27, 64, 125. What is the next number? What is your conjecture? Very good! They are the cube of the first 5 terms or first 5 numbers. Thus, the next number is 216. For number 2, we have numbers 4, 20, 100, and 500. What is the next number? What is your conjecture? Very good! The numbers are multiplied by 5 to get the succeeding numbers. Therefore, the next number is 2,500. For number 3, we have numbers 1, 1, 2, 3, 5, and 8. What is the next number? What is your conjecture? Very good! The numbers next to each other is added to get the succeeding terms. Thus, the next number is 13. Now, let's proceed with patterns in objects. Draw the next object in the picture pattern. We have a triangle, a square, and a pentagon. What is the next object? Very good! The next object is hexagon. How about the next one? What is the picture pattern? Very good! The shaded part of the image is now at the lower left bottom because the image is rotated in clockwise direction. At this point of the lesson, you are about to learn the introduction to sequences and patterns. To understand better how to generate patterns, you will have to perform this simple activity. For our materials, you will be using a string and a pair of scissors. For the first step, I want you to prepare 5 strings with equal lengths. Next, cut the first string once. How many pieces are there? Very good. Next, cut the string twice. How many pieces are there? Very good. Next, cut the third string thrice. How many pieces are there? Very good. Next, cut the fourth string 4 times. How many pieces are there? Now, cut the fifth string 5 times. How many pieces are there? Very good. Now, without cutting a string 6 times, how many pieces are there? Have you seen a pattern? If yes, describe the pattern and state your conjecture. Use a formula or equation in your conjecture, where y is the number of pieces and x is the number of cuts. Based from the task, the complete solution is shown in the table. From the table, notice that the number of pieces y of strings is 1 more than the number of cuts, which is x. Thus, we can say or we can state our conjecture as the number of pieces y when a string is cut x times can be computed using the formula y is equal to x plus 1. Using the formula y is equal to x plus 1, we can now solve the number of pieces of strings that can be made from 12 cuts, 24 cuts, 35 cuts, and 42 cuts. Now, were you able to get the same answers? For 12 cuts, the number of strings is 13. Very good. For 24 cuts, the number of strings is 25. Very good. For 35 cuts, the number of strings is 36. And lastly, for 42 cuts, the number of strings is 43. Very good. Were you able to get the same answers? If yes, very good. If no, I hope you were able to understand the discussions above. Based from the given activity, the number of pieces y is equal to x plus 1 when a string is cut x times represents a sequence. Thus, the values of y, which are 2, 3, 4, 5, 6, 7, so on and so forth, is an example of a sequence. But what is a sequence? Sequence means an order in which one thing follows another in succession. A sequence is an ordered list. For example, x, 2x raised to 2, 3x raised to 3, 4x raised to 4, and 5x raised to 5. What is the next term? Very good! The answer is 6x raised to 6. A sequence is a set of objects in which is listed in a specific order, one after another. Each member or element in the sequence is called term. But what is a term? The terms in a sequence can be written as a sub n, a sub 1, a sub 2, a sub 3, a sub 4, a sub n, which means a sub 1 is the first term, a sub 2 is the second term, a sub 3 is the third term, and a sub n is the nth term, and so on. Now, sequences are classified into two types, finite and infinite. Now, what is a finite sequence? A finite sequence contains a limited number of terms. This means it has an end or last term. For example, days of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Number 2, the first 10 positive perfect squares, such as 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Now, what is an infinite sequence? An infinite sequence contains a countless number of terms. The number of terms of the sequence continues without stopping, or it has no end term. The ellipsis, which has a symbol of ... at the end of the following examples, shows that the sequences are infinite. For example, counting numbers: 1, 2, 3, 4, 5, so on and so forth. Number 2, multiples of 5. Examples: 5, 10, 15, 20, 25, so on and so forth. So those are finite and infinite sequence. Sometimes, a pattern in a sequence can be obtained and the sequence can be written using a general term. In the previous example, x, 2x squared, 3x raised to 3, 4x raised to 4, 5x raised to 5, and 6x raised to 6, each term has the same exponent and coefficient. We can write this sequence as a sub n is equal to n x raised to n, where n is 1, 2, 3, 4, 5, 6, so on and so forth. And a sub n is called the general or the nth term. Now, let's try finding several terms of a sequence given the general term. Are you ready? Very good. Let's start.
For example number 1, find the first 4 terms of the sequence a sub n is equal to 2n minus 1. To find the first term, let n be equal to 1. Use the given general term, a sub n is equal to 2n minus 1. Substitute the value of n to the given general term, and this will become a sub 1 is equal to 2 times the quantity 1 minus 1. Perform the operations. This will become a sub 1 is equal to 2 times 1, that is 2, then copy minus 1. Simplify the equation, and this will become a sub 1 is equal to 1. Therefore, the first term is equal to 1. Repeat the same process for the second to the fourth terms. To find the second term, let n be equal to 2. Use the given general term a sub n is equal to 2n minus 1. Now, this will become a sub 2 is equal to 2 times the quantity 2 minus 1. Perform the operations. 2 times 2 is equal to 4, then copy minus 1. Simplify the given equation. 4 minus 1 is equal to 3. Now, the value of the second term is 3. To find the third term, let n be equal to 3. Use the general term a sub n is equal to 2n minus 1, then substitute the value of n, and this will become a sub 3 is equal to 2 times the quantity 3 minus 1. Perform the operations, and this will become 2 times 3 is 6 minus 1 is equal to 5. Lastly, to find the fourth term, let n be equal to 4. Use the general term a sub n is equal to 2n minus 1. Substitute the value of n, and this will become a sub 4 is equal to 2 times the quantity 4 minus 1. Perform the indicated operations. 2 times 4 is equal to 8. Then copy minus 1. Simplify the given equation. 8 minus 1 is equal to 7. Therefore, the first 4 terms of the sequence are 1, 3, 5, and 7. This is now the answer.
How do you find the first example? I know that you want more. Let's move on. Now, let's find the general term given several terms of the sequence. For example number 4, in your module, write the general term of the sequence 2, 4, 8, 16, and 32. Notice that each term is 2 times the previous term. We can search the pattern using this tabular form. Therefore, the nth term of the sequence is a sub n is equal to 2n, where n is equal to 1, 2, 3, 4, and 5. I hope you get that. Very good. For example, number 5. Find the general term of the sequence 1, 1/4, 1 over 9, 1 over 16, and 1 over 25. For the solution, write 1 as 1 over 1. Notice that the denominator is an integer square. Therefore, the nth term of the sequence is written as a sub n is equal to 1 over n squared, where n is equal to 1, 2, 3, 4, 5, so on and so forth. I hope everything is clear. I know that you are all excited for the next part of our lesson. To ensure your full understanding on the concepts related to generating patterns, it is important that you are able to complete the following statements. Write your answers in your notebook. Number 1, a sequence is blank. What is your answer? Number 2, a term is blank. What is your answer? Number 3, a finite sequence contains blank, while infinite sequence contains blank. For number 4, to find the specified terms of a sequence when given the general term blank. Lastly, for number 5, to write the general term of a sequence when given some terms blank. Very good! Now, for the last and most exciting part of our lesson, Let us determine how much you have learned from this lesson. Read and understand each item, then choose the letter of answer and write it on your notebook. For number 1, which of the following defines infinite sequence? Letter A, days of a week. Letter B, teenage life. Letter C, every other day. Letter D, first Fridays of July 2021. For number 2, what is the 11th term in the sequence -1, 4, -9, 16, and -25? Letter A, 100. Letter B, -100. Letter C, 121. And letter D, -121. For number 3, find the first 4 terms of the sequence A sub n is equal to 3n plus 2. For letter A, 5, 7, 11, and 14. For letter B, 5, 8, 11, and 15. For letter C, 5, 8, 11, and 14. And for letter D, 5, 9, 13, and 17. For number 4, what rule will correctly describe the sequence 2, 6, 12, 20, and 30? For letter A, n plus 1. For letter B, n squared plus 1. For letter C, 2n plus 1. And for letter D, n squared plus n. Lastly, for number 5, find the nth term of the sequence 1/2, -1/4, 1/6, -1/8, 1/10. For letter A sub n is equal to -1 over 2n. For letter B, A sub n is equal to -1 raised to n plus 1 over 2. Letter C, A sub n is equal to -1 raised to quantity n plus 1 all over 2n. And letter D, A sub n is equal to -1 over 2. Write your answers on your notebook. Now let's see. What is your score? Congratulations for doing your best. Now, that concludes our lesson for today. Always remember, math is fun and exciting. Goodbye!
Thank you for trying this demo.
Let's go hawak kamay, together we will soar high. Let's sing with a smile, OCNHS-TV. Talino at galing aming sulong, edukalidad aming
Thank you for trying this demo.
sulong. Tagumpay ating matatamo, basta't hawak kamay tayo.